Now, up next, we're bringing up Mr. Moses Bumera, a data scientist. Um, please, Igor, please, the slide. Switch the slides, please. Okay, second, next we'll have our guest speaker, Mr. Moses Bumera. Mr. Moses Bumera is a data scientist at Imata with a passion for using data to solve real-world problems. He has experience in machine learning, natural language processing, and computer vision. Moses is also a strong advocate for open source software and open data. So, Mr. Moses, the floor is yours.
Thank you, Esther.
No.
Oh. Sorry, thank you, Bola.
Yes, thank you. You're welcome.
All right, let me share my screen. All right, I hope you can see my screen.
Yes.
Yeah.
Okay. All right, as Bola said, I'm Moses Pamera. I'm a data scientist at Imata, Uganda. A little bit about Imata. It's a fintech based in Uganda, and what we do is we use data science for risk management to give out financial products to agricultural based entrepreneurs. This is mostly farmers. And the idea or the gap being filled here is that these are people that can't get or access this finance or credit from mainstream banks. And well, using data science, particularly machine learning, we're able to extend this credit to them. I also work as a machine learning engineer at the Makoni Research and Innovations Lab. It's based in Makerere University, and it's mostly research work that is also in agriculture, health. Yeah. My talk is going to span mostly on the data science side of things and try to take us to a place where we look at the state of AI in today's world and some sort of practical guidelines for the graduates. And congratulations to everyone that made it to this step. Yeah. So I'll start with data science. And so these are terms that, well, I think we've all heard here and there. And there's data science.
Sorry about that. You can continue.
Okay. Yes. So at the core of it, data science is quite a broad field, and it's essentially the science of data or the study of data to come to some useful meaning from whatever data it is that you have. Like in my case, the question I'm trying to answer in my daily work is how much credit can be extended to a given farmer, and from the data that we have. Data science encompasses a number of things. At the core, there is the math and the statistics. Then there's the programming and, well, the domain expertise. So, as someone in the field of data science, you probably uh, work in a field that you're probably not familiar with, maybe health or agriculture or finance. And the domain expertise, or at least the understanding of the field you're in, allows you the ability, or at least to understand how to model some of the things that the data that you have. in line with what actually happens in that said field. So under data science, or as a means of achieving the objective of extracting meaningful insights, one of the ways that can be done is by using artificial intelligence. And artificial intelligence, as most of us might know, is a simulation of human intelligence, like trying to do tasks that have for a while been a reserve of humans, but now machines are being gotten to actually perform some of these tasks. And artificial intelligence is also a broad field, and under it, one of the most popular ways of achieving artificial intelligence has been machine learning, which is teaching a machine or exposing a machine or an algorithm to some experience or a real world activity through data. So using that famous example of classifying cats and dogs is, how do I teach a computer to identify cats and dogs? You get a number of pictures of cats and dogs that are labeled that this is a cat, this is a dog. And then using a machine learning algorithm, you could train it to actually also be able to do that. Then under machine learning, there is the more dominant approach that is called deep learning, which is loosely based on how our brains function. And in fact, you probably heard of neural networks and neural nets. So this is actually built based on how our brains perform, specifically the neurons and how they activated. But of course, as the field has grown, this has moved further from this and more to just a mathematical approximation of certain algorithms. So this takes us to what the space of machine learning looks like, or artificial intelligence at the current moment. So this is from Cargo AI report of this year, and these are some of the, I would say, high-level fields that are out there in the field of artificial intelligence, starting with generative AI, which I believe most of us are now familiar with. This is the realm where ChatGPT and the likes of DALL-E fall. Essentially, what happens in generative AI is uh, the algorithm is built or taught from a body of text or images in the case of the image generation. And the task is to create something. I'll not use the word original, but it's a combination of what it has learned from the tons of data that it has been exposed to. And yeah, the examples of this are the large language models like ChatGPT, Llama, or the image generations like Midjourney and DALL-E. There's also another subfield that is quite big, that's the text data. And under this, uh, the tasks like understanding what a sentence means. So this is also something that is under generative AI. Like when you prompt ChatGPT with a question, it understands the context and what you're talking about and tries to give you an answer in that regard. But under the text data, there are more things like classifying, let's say, for perhaps social media, maybe toxic posts. That's one of the things that are under this field of text data. But also summarizing, like let's say you have a big document and you'd like to reduce it to its core points. So the line between generative AI and text data is actually quite thin, but there are few subtle differences. The other very dominant field is the image and video data, and this is actually, I believe, what brought AI back from a very long winter where there was actually no activity with the computers being able to perform tasks such as identifying objects within a picture or a video. And with the advent of a technique called transformers, which is an algorithm under the deep learning field, they have actually gotten much better. The other type of data or field of AI is the tabular and the time series. Now, this one is quite important, or it is quite important because it's one of the most common subfields most people get to encounter. And I imagine most businesses have this tabular data where you have a definition of a problem and sort of a label of like a description of, let's see, I'll use machine learning terms. You have what is called the features or something that defines, let's say, like an image of a dog, maybe the shape of the ears or the eyes or the color of the eyes or the fur. And you have the label, which is the word dog, which says this set of features is actually mapped to a dog. So in most business cases and things that have data available, it's mostly tabular data. So tabular data, you can think of an Excel where you have features in some columns and then you have some sort of label. Another example I can give is, say, cancer diagnosis or cancer images. If those features maybe could be turned into some numerical numbers, you'd probably have some set of features and then you'd have a label. This is positive or this is negative. Then time series data, while not exactly tabular data, is simply data that sort of has a timestamp, or the data happens in a way that it's sequential. One thing happens after the other. And this is common in finance. It's actually the kind of data I work with every day where the data is tied to a certain day or a certain time. And there are traditional methods that I think are still quite relevant, but also machine learning and deep learning have had quite an effect on this in terms of improving accuracy and solving forecasting problems. The final field that I think is just cropping up, uh, given what AI has been able to do, is the field of ethical AI. So this is essentially for those of us that develop, and I guess the users too, uh, the responsible development and use of artificial intelligence. So while it can be used to solve all these actual problems that people are facing, it can also be used for, well, uh, not very positive endeavors. So, as people in this field and on the development side, the number of ethical considerations to make in terms of not propagating bias. Like, you could imagine if a large language model is trained on text from the internet, there's a lot of, I would say, racism or bigotry or the nuances and biases of us, the human populace. So if that is used as a training data set for a given model, then it's highly likely that it will propagate the same things. So it's important to also have this ethical perspective while doing the mathematical implementations. All right, so I believe most of us in this call, the graduates, are at a level of starting out in the world of data science or artificial intelligence. And this is more from, I would say, what a typical journey would look like. And one of the most important things, at least I have experienced, is knowing why you are doing data science. Is it because it's popular at the moment, or is this something that you're actually interested in? Because not until I think 2014, AI had been quite quiet for a while due to a number of things like lack of delivering on the promises that had been made a few years before, and like funding, etc., the things that dried out. But then with the advent of the neural networks and computer vision tasks where computers could understand images, AI was back, and that sort of boom is what is happening up to today. So it's important to know why you're doing it. And if you are convinced that this is the journey you want to take on, then when you're starting out, I imagine there's a lot of information or different ways that you could actually go about this. From my perspective, I would say it's important to expose yourself to, let's say, the different sections. Like we've seen, there's a number of things today. If you learn to AI today, you probably think of ChatGPT and the large language models. But there are a lot of things that actually are under this field that could also be of interest, and I think are actually more practical for our communities, especially the tabular and time series data. So it's important to know about this. That way you sort of uh, have some informed decision on what field within the space to pursue, because then doing everything is also not a very good idea. It's better to be a master in something than know bits and pieces about very many different things. And then, so when this is clear to you, or if it may not exactly be clear, but to a certain extent, I would encourage that you actually pursue it. So this depends on where you are. I mean, for some people, a university degree might be the best way forward. For others, maybe self-teaching is possible. All these paths can lead to, I believe, a successful career in data science or machine learning, of course, depending on the requirements of either the industry space or academia. So that is also important to figure out. And I have a few recommendations from the few things that I've experienced that I think could guide someone in going deeper into this journey. So for most AI related courses, or I don't know, maybe literature, blogs, etc., you'll probably start with the data science itself and the analysis. And one thing that is usually ignored is the programming, which is quite important because the entirety of the skill is built on your ability to program. There are tools, of course, that say things like data analysis. You could use Power BI and tools of the sort, which might shield you from the need to know, say, actual programming. But I believe if you would want to contribute to a broader space, programming would be a skill that is very necessary to have. Then the other thing is there is so much information out there, which can be overwhelming, and you might not exactly know where to start, or you could find two, let's say, courses that are all talking about AI, but talking about different things or presenting things in a different way, which could be conflicting for someone who does not have a very deep background in this. So for that, I would recommend getting like a mentor, someone who has had experience in this field that will usually shield you from, first of all, the overwhelming information, so to break it down for you, but also perhaps point out some of the early pitfalls or errors or mistakes that you could make, which, well, is just a much better learning experience. Uh, the other thing that you could do to learn or understand what the state of machine learning is like out there, these competitive platforms. There is Cohort, there is Zindi and Driven Data. If you're particularly interested in African problems facing African communities, Zindi is the place to go. It has locally sourced data sets that are actually, well, they're actually solving real world issues. And as someone on a learning journey, it's usually important to know or translate the knowledge you've learned from, say, the course that you just graduated from, and see the value it actually has on actual real world problems. So Zindi is a good place because you actually be solving things that you can perhaps relate to. Cargo is more international, and some of the competitions might be a bit challenging, but they do have entry level competitions too that you could perhaps check out. So this is, in a sense, an addition to the learning that you might be doing, whether it's a university degree or a self-taught course. It allows you to see the value of what you're learning in a real world setting. Then the final thing I would say is joining a community. So I believe Eloquent Data is one of those. The other community I would encourage, especially for people on the African continent, is the Deep Learning Endeavor. It's a grassroots organization movement started in South Africa that aims to bring together machine learning, data science, data analysts, practitioners within the same space. They recently had a summer school in Ghana. Yeah, so this is it's a very good community to be a part of. The other importance of the community is when you're with people that are pursuing similar things, it's a lot easier for you to find your way. Yeah, that was the chat I had or talk I prepared today. Thank you for listening. If you have any questions, I believe still have some 3 minutes.
Hey, if you have any questions, you can ask, please.
All right. If there are no questions, I think I will stop here. Thank you very much.
Okay, thank you very much, Moses Bumera. Thank you so much for that insight on the types of data and AI ethics. Thank you so much. And you also enlightened us on communities to join. So over to the graduates, you've seen and you've learned from Mr. Moses Bumera. Thank you so much once more, Moses Bumera, for that.